Last but not least, problem number 3 for the 4-1 notes. Here we go. Rocket tree. Ooh, I like that word. That's a fun word. Rocket tree. A model rocket rises quickly and then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute opens, after which it falls slowly back to Earth. What sketch of a graph could represent the height of the rocket during its flight? Label each section. So here we go. They do a really good job of labeling all this. I like this. So here's your independent variable. Here's your dependent variable. The height depends on what time the rocket is in the air. So let's see here. It's flying up relatively quick. Starts to slow down. It runs out of gas somewhere, and then out of gas. We are completely out of gas. Probably over here somewhere. Just the initial burst of the gas would get it up here, because I think somewhere around here it'd run out of gas, and then it just runs out of energy. Eventually gravity starts winning at this point. So it starts to fall before it falls too quickly. Boom, parachute. Okay, they label everything awesome right here, okay? So they label everything pretty awesome, and then once you float down, it's nice and consistent. It's falling at the exact same speed. It's falling slowly, okay? So just some general things here, students, about this graph that I like, and then, oh, by the way, it hits the ground right here, okay? So a couple of talking points. If you're moving up, that means you're increasing. Now, if you are a little bit more steep, this one is increasing way faster than this one, okay? So this is definitely fast, and this one's a little bit slower. All right, same thing when you're falling down. When you're falling down, going down right here is way more aggressive. This is falling quickly, this is falling slowly. So this is just a little bit slow, this is a little bit fast. All right. The other things about graphs such of this nature is that if you were ever going straight across, then nothing's happening, okay? So nothing's happening. I mean, in terms of height, you're staying the same height. So nothing's really happening. Nothing, I guess I can say that nothing changes. Okay, you're staying the same height. If you're going straight across, nothing changes. And then just some other key points. Obviously, this would be the ground. Okay, and this would be known as the max height. I was going to ask you a question about that. Max height. That's about it. Things start at 0, 0. Obviously, you don't keep track until things begin. Most things begin right here. Oops, and my lights just turned off. Sorry about that. Let me get them back on. Hey, and we're back. There we go. That's about it for that one. Yeah, there's nothing else I really want to point out. This is wonderful here. Okay, so let's go from a nice, pretty, organized one to one of my rough sketches. So here we go. Oof, I'm a little nervous about this. Here we go. Suppose you start a swing yourself on a playground swing. To swing yourself on a playground swing. You move back and forth and swing higher in the air. Then you slowly swing to a stop. What sketch of a graph could represent how your height from the ground might change over time? Label each section. So then part B, what's the difference between slowing to a stop and then if you jumped off from the swing? So here's my rough sketch. So don't hate me, but again, it's just a sketch. First of all, it doesn't even go straight, so I apologize that. I probably could have used a ruler, but hey, you know what? I rushed it just to get it done, and I'm sorry. Usually I take pride in my quality, but you get the idea here. All right, so you start swinging. Okay, so this is at the bottom of the swing. You swing your feet forward, swing back down, swing your feet back, down, like you swing down, forward, down, back, and then, you know, after a couple of swings, you're at your max height. So you get the maximum height you get. There's your max height. You swing back down, max height, swing back down, max height, swing back down. And then as they start getting smaller, that means you've just stopped pumping your feet, as I say. So when I teach Hadley and Brindley how to swing, I pump your feet forward, pump your feet back. And so this would be the spot where I probably stop pumping and then start slowing down. Then eventually, obviously it'd probably be a few more swings than this, but eventually when you come to a complete stop and you don't move anymore, your height is not going to change. Okay, so going up, going down, max height. Notice I tried to keep it all about the same height in the bottom because your bottom's not going to change. Okay, you would stay at about the same height on the bottom of your swing, but the top of your swing is what would change as you keep going up and down. Now, part B says, what would you do the exact same thing, but instead of slowing down, what would happen if you just jumped? Well, I kind of try to copy and paste the same thing. So here's my height, here's my time, over time, swinging, harder, harder, max height, and then boom, jumping from the max height. You would probably fall pretty quickly, boom, land on the ground. And then that's it, you're done. So again, there's the ground. So what's the big difference? The height would be the difference. If you just stop swinging, you at least stay off the ground a little bit. But if you jumped off of the swing, you would hit the ground. Okay, that's about it, friends. That's problem number 3. All right, bye-bye.